with the team and did an inspection. And you can see here that the team took photos of any defects that they wanted to add, and then we can see exactly where the inspector was standing, where they were located. And I should say this is our R&D environment. So this is not the final product, but we wanted to share with you kind of where we're at, and then we'll showcase where we're going as well. And with that, I'm going to hand it over to Stephen, who is our CTO, Chief Technology Officer, and he will tell you all the exciting things of what is going on at that back end and how we're making this all work with those big volumes of data from UAS and small volumes of data from the site inspection.
Thank you, Victoria. Yeah, and it's good to see everyone here. So we have a hybrid data workspace. Headlight has about 7 or 8 years of experience capturing millions of photographs from job sites. And I think about 2 years into our work with ALDOT, we realized that we could capture extra spatial information. And we have a data lake that intersects the photographs with quality data, quantity data, any kind of problems or defects, and other types of labeled information going back in time from historical data sources as well as from inspectors. And so the platform has the ability to capture many observations, and the inspectors can then use that in this hybrid digital and workspace where the office can see in real time what is happening on the job site or on the bridge that's being inspected, including intersecting things like 3D models, overflight data, observations from folks that are standing on the job site in real time, as well as sending things like maintenance crews out to the locations. All of the data that's captured can then be put into reports without needing to be retyped or be refit in any way. That's the core of the way that our data platform works, is that we capture once, and then the data is reused over and over again. Further, the way that the data is cataloged and put together on the back end allows us to ingest data historically from BRM. So we can intersect both the old format of the way that the bridge element conditions are stored, as well as the new format, the way that the bridge elements are now being switched to with the new BRM. I think it's version 3 or 4. In addition, we are automating the pushing and pulling of data to and from BRM. So when an inspector performs an inspection and fills out the form and approves it, it ends up being automatically uploaded to the BRM format in a ready way to get pushed to the FHWA at the time of the year when all of that data needs to be put together. I think the holistic view for Headlight and the data platform in general is to get as many sources of data into the digital hybrid workspace as possible so that inspectors, engineers, and other folks can take a look at the data either in the field or in the office at the same time. So we have now completed pulling in the data historically for both Alabama and Hawaii, which are our 2 pilot customers that we're working with to fill out the forms in the field. And we've started the process of building the capture technology in such a way that it can be done both in the field app or in the office. Part of the communication that this allows is that the field folks can capture data in real time with location information to direct maintenance crews exactly to where they're standing on the bridge. And so if there's a specific span or a specific element, that location data is attached to each piece of information that was captured in the field with our application. All of that indexing happens. We actually have a large body of observations that have been captured so far with that location information for Alabama that will be part of the beginning of building the forms that are being submitted, I think, even this year. The last thing I wanted to get to was the scale of the data and what we're looking at. Right here, this is, what is it, about 4,700 images that were used to generate a massive amount of high-quality geo-rectified imagery that we can put onto a map and use as part of this inspection environment. And so during the course of a bridge inspection, if we take in say 2020 or 2022 or 2024, as Victoria was saying, looking at the condition of that bridge over time, we can actually overlay all of the data that was captured across those inspections and see it alongside things like construction data or maintenance data that was captured in between those times. And so if there was a project that happened that dealt with a bridge approach, or if there was a repair that occurred for a specific span or a specific element, that data will be available to the inspector while they're on the job site holding their device, whether it's an iPhone or an iPad. That back and forth communication between the office and the field is one of the ways that our data platform really helps communication happen in two directions that's not possible with a paper process or even web-based tools, because it happens in a hybrid online-offline way. And now, any questions?
Maybe before we do questions, I just wanted to add that the goal, or like my dream with this, especially coming from the design side and thinking about this in the whole context of that bridge life cycle, is that by actually capturing the data in a way that is meaningful and useful and not in either a PDF or on a shelf somewhere in a really nice office, is that we can then start to feed that back. You know, this is a long-term goal, like 20, 30 years that I have, but that we can take the information that we have from maintenance, you know, where are our elements the worst? Which materials were they being used with? Why were those bearings like degrading 5 years faster than they should have of their 20-year lifespan? And feed that back into that design side and making sure that our whole infrastructure life cycle then gets closed. But the start to being able to do that is actually collecting the data and the information in a way that we can use it, interrogate it, and then make decisions. So it's a small dream, but there you go.
It's a wonderful dream.
And now questions.
And now.
Yeah, we can hear you, and we'll repeat the question.
Okay, you talked about the iPad being too cumbersome for the bridge inspectors and switching to a phone app. Phones can be a little bit hard to enter data, or like they preferred the smaller one, like even if it was harder, or do you want to talk about like the compromise you had to do between the iPad and the iPhone?
Yeah, that's a great question. So the iPad app that we use, Fieldbook, has been in the field doing or performing construction inspection for quite a while. And like I said, we capture millions of photos with it every year. I think the reason we switched to the phone was because, by and large, every single inspector requested to have the app on their phone. And we really hadn't tried to deal with that challenge before of taking the format of capturing data, labeling it, assembling it together so you can see more than one piece of information at the same time. What we noticed was that when people were going to the bridges, they were spending a lot less time synthesizing the data that they were looking at. So whereas when we were doing construction inspection, someone's on the job site for 8 hours a day holding this iPad, it's replacing a tablet that's full of paper, and there's a lot of information they need to consume while they're doing that process. When they're looking at the bridge, they really need to capture one or two small pieces of information for a specific location at a time. And so showing them just the bare minimum of what they need for the position in the bridge that they're at allows them to focus on their environment and surroundings more. It was a pretty big difference between what we saw with our iPad app and the iPhone app, and it took a while to really understand why that format was so important for them. But it was at the request of the inspectors.
Yeah, I was going to add to that, that they went out with iPads, tried and tried. They're just set on their iPhones. They wanted that app, and that's another example of we scope changed on a headlight, and they worked with us to make it happen.
So as a bridge inspector, I can kind of point to that. Not every inspector has an iPad. I prefer to use the iPad because I can see pictures better. But a lot of times when you're crawling around under, on, over, inside a bridge, an iPad can get very cumbersome. So I could see the benefit of just having it on a phone. My question is, you mentioned that you can fill out the forms in the field or in the office. Is your idea that you use like a digital twin in the office to do the actual inspecting, and you're just out in the field collecting data however you need to collect it, go back to the office, fill out the form, and then upload, or is this purely a field app type of thing?
Yeah. So the overall goal is to minimize the amount of time that the inspectors have to take to do an inspection. So that's the overall goal. And one of the ways in doing that is to allow people to go out, collect all that information either on the iPad or the iPhone, and then that goes through and is a report, and they never have to look at that again, apart from the people who are approving it. But the actual inspector, that all gets collated. If you've got 5 inspectors, it brings all that information together, and then it's there, can be sent through that approvals process. There might be situations where you're doing a big bridge, or you're doing a complex structure, or you want to be able to add a photo that you took from your drone to your inspection report. And so that's where then you can bring that together in that hybrid workspace, and you can add that to all of that information that was collected in the field. It would not be a requirement that you have to then go back to the office, do that all through that workspace. In terms of digital twin, I don't know if anyone went to AECOM's talk on what a digital twin is, but I loved it. Because they did a very good definition of, we all have very different ideas of what a digital twin is, and a project might have many of those, and to them a digital twin is what I think of as a digital twin, which is a kind of live living model of everything, and I see us being a part of that, and this information is part of that overall asset management life cycle. So I hope that answers your question. Okay. Yeah, go.
Just to expand on that a little bit, the form could be filled out in the field, the form could be filled out in the office, or it could be filled out in both, which is how we do our construction inspection currently. The form getting generated and starting to be filled out, it might happen in multiple places or multiple sessions or even back and forth. The idea is to provide a flexible environment to do that inspection in.
So I'm not sure how other states work, but in Oregon, our bridge inspection data and our bridge inspectors themselves are really heavily tied to our linear referencing system. And so when we try to bring in geospatial type tools, there's a lot of pushback, there's a lot of uncertainty. How do we navigate between, a geospatial experience and then these linear referencing experiences? So do you guys, have you encountered that through your pilot projects? How do you navigate that? Do you have any examples maybe how you can show what you guys are doing there?
Yeah. So far, at least with the agencies that we've worked with for bridge inspection, we've not dealt with the linear referencing system for bridge inspections. In construction, we have, quite significantly actually. We do have our inspection product, Fieldbook, has full stationing capabilities as well as geospatial capabilities, so it does both. And so inspectors don't have to do geospatial, it happens automatically through the technology. Basically, when you're standing there, even if you type a number in, it knows where you were standing when you were typing that number in. However, there's also positional entries where you can say the stationing. In fact, there was actually stationing information on the flash of the inspection product that she had there. So our inspection tools do work with LRS, and there's a number of ways that we can set that up. It really depends on the project type. I'd be really interested in talking to you about how you're using that in your bridge inspections.
on your inspection reports there, does does it communicate with BRM prior to the inspection and pull down the necessary elements for that particular structure, or does the inspector have to log the individual elements in the field or tell it which element it's looking at? Because I know typically, at least the workflow for my inspectors is they go out, they've got a report, all the element data is already in there, so they don't have to look up whether, it's element 225 or 220 or, all that's in there for them already, and they're just updating quantities and inspecting the elements rather than doing an inventory.
Yes, great question. So we have ingested all of that data and that information for all of the bridges from Alabama and Hawaii. And then for each individual bridge, they each have their individual bridge reference number. And then each one of those can be its own project. There's scope for how that looks and how that interacts with each DOT. But they don't need to go and fill out or like pull that data themselves. That will be pre-populated in the form, and they'll have all of those defect types, element types with the corresponding numbers that you need to have to be in compliance with FHWA requirements. Because ultimately this is about like streamlining your workflows. So we don't want to add in another step that they have to do. We have all that data and the information for comparison. Yeah.
We do have the specific elements though, so it does know the quantities and the elements and the type for each bridge that's listed with the FHWA. Just to directly answer that, yeah.
Thank you.
Thank you so very much.